previous video was about combinations. In this video I want to implement the all possible subsets of a set. The set will be represented as a list, and for generating all subsets we will use a combinations functions which was implemented in the previous video. So you can watch this. I will put link in description. Okay, we have this combinations function which take some list and number of choosable elements, for example 2, and we get all possible combinations, pairs of combinations. We can also take triples. So how can we construct functions of all possible subsets using this function? Obviously we can do this by producing all possible lists from 1 to length of the list. So we take 1, take all possible combinations by 1, we take 2, take all possible combinations by 2, take 3, and so on. And let's write this function. I will call it subsets. I will call it SS. Subsets. Okay, and it takes list, and from this list we need to produce all possible subsets. First of all, we need to take a range from 1 to length of this list, and then we need to fmap in this range combinations function, partially applied with our list XS, and let's check what we will get with this. I will load the module and call it our SS function. You can see that we take all possible subsets, and we have some extra level here which we need to remove, and I will remove it with join function from monad module. I need to import monad module control.monad, and we have join function here. It will remove the duplicates. So let's reload and let's check. Sorry, it will not remove the duplicates, it will remove one layer. So you can see this type signature. And now let's check it works. As expected, we get all possible subsets of a set. Yes. But there exists one more interesting solution, and it is more short. Let's look at this. So I define this function as S, and it takes of course a list, and in the case of empty list it returns me a list with one empty list. But what if we take some list what contains some elements? In this case we need to take all subsets of its tail, of its excess, and we pick one element. It is a X, and to produce a final result, we need to add here some subsets of XS, and for every of this subset we need to add X, partially applied to const function and with X, be applied with X, and we fmap this final function to our subsets. So we add to every subset the X, and we can see that this will be the correct final result. Let's check this function. Subsets 1, 2, 3. We can see that we have all the subsets here, and we have an empty set here because the empty set is a subset of every set. But exists one more interesting solution, and to implement it we need some function which I talked about in a previous video, which called Cartesian product. We need generalized Cartesian product. This is a TRN function. I copy it and move it to my comp file where we're talking about set of all subsets. So, and let's reload this file and run this function. For example, for a set from with 0 and 1 element, and I want every Cartesian product, the n will be 3, for example. And you can see I get every combination of 0 and 1 chosen 3 times. Okay, this is every Cartesian product with triples. And now this brings us to the main idea: how can we get the set of all the subsets. This thing encodes to us any possible choice of the element for a set with cardinality 3. Okay, and let's just use this function to implement this selection. So let's call our function SS. Again, I will comment this line here, and of course it takes some list XS. And first thing I need to do, I need to take length of this list XS, and I need to generate Cartesian products of 0, of 1 and 0 of this length. Okay. Then I do this. I will get a list of these triples. Now I want to fmap this thing, so I want to apply some function, some lambda function, which takes this triple. I will take name C for this triple, and it need to produce my combination, my subset. Of course I can build this subset using our C, our choosable combination, and our XS, which contains all the elements. I need to zip our XS with my C, and then I need to I will get the pairs, okay, and I need to filter this thing, I will use list comprehension here. So I take all possible pairs. I take the element x here and my marker 0 or 1. I will call it F, like a flag. So, and this select, of course we want to only select x, but if the select is the flag, if the flag is equal to 1, okay, 1 means that we pick up this thing. Okay, let's try to reload. Okay, the problem is, okay, I think I need to put parentheses here and reload, and it's done. And let's check our all subsets function. Subsets 1, 2, 3, and I think it worked. Yes, let's check the length. Yes, I think this is a correct work for our function. Some corner cases. Yes. But there exists one more beautiful, interesting solution, and I put it here. It's look like this. This is a power set function which use filter m function, and I'm not going to explain how it works, but I will give you a tip to understand how it works. The tip is it uses a list monad, and it uses some idea from our previous example, so you can think about this or search the internet, of course. And the last implementation for today using fold r function. Okay, I a little bit rename all the implemented power set function with its numbers. So this is implementation number 5. Okay, it use fold r. We just makes lambda, which takes x and accumulator, and it add to this accumulator the choosable by folder x, every x, and map it to accumulator. So we took our initial accumulator, we start from the empty set, and then mapping it with every element, and do the concatenation of this list. So, okay, we look at 5 implementations, and I think this is enough. So guys, thanks for watching. If you know some interesting implementation of a power set, please feel free to put it in the comments. And thank you for watching. Push subscribe, push like, and sorry for my English. Bye bye.